Welcome to another episode of Energy Bites. I'm Bobby Nealon. I got my trusty co-host John Calfan here.
How's it going, everybody?
What's up? What's up? And we've got Scott Sempton here with Kappa. He's a self-proclaimed computer graphics alchemist. Or maybe someone called him that. I don't know.
Working title.
Yeah, it's a fitting title, though,
Yeah.
considering your background.
Yeah, no, I mean, a wealth of experience.
Yeah.
Really excited.
Especially for folks like us who grew up digital and native with everything on a computer. I'm sure you've got some hella stories with all of that stuff, especially on the seismic side. That's actual big data. That's probably the only real big data that we have in the energy space.
I've probably known now we're about 6 or 7 years now. At least I've known you existed and kind of got to know you better as we were
in my second life. You guys met me when I was moving into unconventionals.
But now I'm excited because I honestly, it's not like we worked like together, but I learned a lot just from our conversations with you and some of the folks over there at Reveal.
I don't know if that says more about you or me.
No, it's true though. We were both working on really cool shit at the time.
Yeah, that was
trying to when we were feeling our way out. So you guys gave us some really, John and I were like flying blind. So it's like anything you can give us, please.
Well, and we were also all trying to work together before that was really a thing that a lot of oil field service companies did.
That's actually a shame.
It is
a terrible commentary on the industry.
Yeah.
Because I've had that experience over and over and over again. I had that experience at Shell when I was proposing to work with Landmark instead of having Shell write all their own software. I'm like, this is everybody and their mother's doing the exact same. There's nothing proprietary here.
Yeah. No, but we're doing it, Scott. It's our proprietary thing.
And then you have a lot of really smart people working on the same thing in parallel, and they're not sharing it.
Yeah, they're not sharing it at all. Mm-hmm. And when you propose it, it was like,
are you crazy?
Yeah.
Year after year, this happens. And then it wasn't really until Reveal that people really started to say, we don't have to compete at every intersection of this stuff all the way down. And in fact, at a startup, you can't. Right?
No.
You wouldn't make it.
So, I think, we've been talking about kind of a little different format, and we want to jump into it. Let's start, you're calling this your second life, let's start with your second life and let's talk about, kind of that reveal through where you're at now. And then we can I'm sure we're going to start pulling back layers of where it all started for you. But,
Reveal so I was employee number 3 at Reveal, small startup in unconventionals, as you guys well know, doing completion design analytics, I guess is the best way to put it. Really cheap or really inexpensive.
Especially really, was it like you were targeting microseismic at the time, right? Like you can get the same kind of results. Yeah,
but we kind of equated it to saying, if you go do an MRI or you go do an X-ray or you go do CT, whatever it is, that's a scanning process, but you're trying to get to the same answer, right? You're trying to look at, a joint or a knee or whatever it is you're trying to look at. And for us, it was the same sort of thing with microseismic, even with fiber these days, whatever it is, you're trying to decide how big are my fracs, right? Sure. What should my well spacing, whatever this is. So we just devised a unique way of doing that with surface pressure only, which made it inexpensive, easy. Easy. We didn't have any people in the field. We didn't really affect operations, so they liked us because basically
wasn't invasive.
So it was really just another way to do the analytics to try to get to that answer, which of course no one ever really knows for sure what that answer is.
So with that, how did they get started? So I'm sure there was. So when you came in, did they already kind of have like the science built out or whatever, and then like
we were a spin out of Statoil.
Yeah,
at the time was Statoil, and they had I wouldn't say proven the technology, but they had put the research in and thought they had something. And because of the way their government restrictions worked, they couldn't run a service company.
Yeah.
So they had to spin it out to realize the value, and they didn't want to continue doing it themselves because they just didn't. They knew they needed to expand it to get it to really be and put it in production.
Sure.
You mean collaborating on oil and gas data makes better products?
Exactly.
I mean, if anyone understands it, it's Equinor, though. I mean, like they've done a lot. Open sourcing some of their data. And stuff,
they did a nice job of spinning us out, and then away we went. So so they had the base technology. In fact, the two fundamental patents are Statoil patents that Reveal has exclusive rights to as part of the spin out. They still own them, and then we ramped up from there. So it was you guys might know Sean Spicer, another industry veteran running around. So Sean was employee number 1, and Erica Conan, who was our chief scientist, who we pulled out of the phone industry. She was doing,
I had no idea that's where she was doing before.
She was doing screens, touch screens. Pressure is pressure, right?
Sure. Okay. Yeah, I never even thought about that.
It was pretty wild to watch her come in and go from sort of micro to
macro.
Yeah, really. Like, I mean,
that's awesome.
So she was employee number 2, and I was employee number 3, and we just started writing software basically.
Nice. So I mean, again, those patents, like they had like formulas and stuff written, or I have to assume there were smart people in there, and were they using MATLAB or something like that? And then did you just have to
turn
that into code? Or?
Yeah, they actually had a web-based prototype up and running when we got up and running. It was, as I recall, it was all Python back end and TypeScript, JavaScript front end sort of stuff.
Nice.
So we took that on, and then Erica was MATLAB. That was her tool of choice. So she did all her research in MATLAB, and then it took us a while. Actually, we went for a couple of years just doing fast prototypes in MATLAB.
Okay.
Until we decided that
could turn it into an actual
Yeah, I mean, we always knew we wanted to do software, and the board at the time was adamant that the software would be one of the assets of the company. And so
just for clarification, software instead of a consulting service, correct?
Yeah, we
were providing reports, right?
Well, Reveal was, exactly. So Reveal was and is to this day a service company. We had a long conversation, interesting startup, philosophy. Like, are you an oil and gas service company?
Right.
Mm-hmm.
Are you a software company? Are you a tech company?
Sure.
Masquerading as a service? Like, what do you do? Our investors and our board knew the service side of things. They understood oil and gas service companies. So we were started as a service company. All the software was internal, but where we not got hung up, but where the board was adamant was they wanted software as an asset, even if we weren't necessarily selling it, either as software as a service or packaged software. They wanted that asset. And there was concern, rightfully, wrongfully, depending on how you think about software, that MATLAB and a bunch of MATLAB scripts was not
software,
was not an asset. And so we started to convert that into a C# desktop app, frankly, because the interaction models were so complex that doing it on a web page, a single page web form or a multiple single page,
that would have been fun.
It might have been the right thing to do, but we had to get
something out the door.
So it was much easier for us to do that
How was that work? Like converting like MATLAB to C#, because like MATLAB and I think R, they're very matrix based things, and then like C# is more like
really entertaining,
object oriented, right?
That's
why they hired you, right?
That's pretty much true.
No, I feel like that's pretty much all I ever used MATLAB for in college, undergrad, was like complex matrix.
It's
equations, right? Like I know it does way more than that.
As a straight software person, you kind of really have to, like every language you think about works in, kind of array format or object format or how you ever want to. Very few of them deal in matrices. And if it is, it's these very small, 4x4 vectors or something.
Yeah.
And you go, you really have to wrap your head around every calculation is this matrix-based thing, and the result is yet another matrix.
Wow.
And
Yeah.
okay.
So does C# have a way to kind of like do some matrix? I mean, do they have packages for that, or is it really just you got to kind of really convert that logic into?
We just translated it.
Yeah.
Frankly, we found for the most part we did it for performance reasons, because we found if we just took the time to do that translation, that we could outstrip MATLAB's performance.
Sure.
Hands down.
Yeah.
At every turn.
So
especially when it comes to memory management.
I was going to say, talk about that more, because y'all were doing quite a bit of complex kind of computation and heavy lifting, at least from the outside looking in.
Mm-hmm.
So I assume it's probably even more complex than I realize or assume that it already is. But talk about that, because again, I do think, and not that this is necessarily seismic data, but y'all did use seismic data, I know, a lot for validation or supplementary type stuff. Like that's, as we've mentioned, kind of the only true like big data set in the industry. So it's not like doing what you were doing minus the whole big data complexity is complex enough, and then tacking that onto it makes it even more fun. So just talk about some of the, trials and tribulations of that, things that you would do again, things that you wouldn't do again.
Oh, geez. We spent so much time prototyping in MATLAB that, which wasn't necessarily a bad thing. But the nice thing was we really had the workflows down, because Erica had really worked through them in MATLAB. And so we were really about figuring out how to do that efficiently, effectively, and in a way that we could expand it as we went. So Sean and I were very conscientious about what our designs were looking like, what our architecture was coming up, which is a little bit, it's the right thing to do for software design, for professional software. It isn't what most people do today, right? Most people today are doing a lot of individual tools, which is effectively how, even Erica would work, was, MATLAB, Python, R.
Yeah.
These are really, in my mind, tools designed for engineers as part of their toolbox, right? I got to answer a question. They're
specifically designed for a
they
specific
don't work
thing, right?
real well for shrink wrap commercial software. It's hard to maintain, hard to sort,
loosely typed. I mean,
loosely typed, which is always a nightmare.
Don't you love JavaScript?
I can't stand TypeScript is a little bit better.
It's a step in the right direction.
And not to be disparaging, but it is so easy to get it wrong. That if you're so I get asked quite a bit, like, what as an architect, what is your job? Because people have a hard time kind of wrapping their head around what is the job of a software architect.
Do you actually use your fingers?
So I finally came to the notion that resonated in some places, that my job as an architect is to protect the investment of the software.
Yeah,
that's a really good.
It's
sentence.
It's really communication.
I thought you were just going to be to tell people no.
Right.
Like,
yeah.
I'm probably saying no more than yes. Like,
we can't at some point, but you have to be pragmatic. If you're going to write software for a living, you have to be pragmatic in your approach. Like you can't stand in an ivory tower and say, but the design patterns say it has to be like this. And this is what a microservice architecture looks like. And this is what this is. And this is what this is. In the end, you have to be pragmatic, or you're never going to get software out the door. So you're going to have to balance
give and take.
But my job as the architect is, and I have a colleague who uses this phrase, is keeping the software soft. It's protecting that investment 5 years down the road.
Right.
Like how many people look at a piece of code 5 years from now, 10 years from now, and expect that to be living on. But those are lessons learned from Landmark. We had software bases that were 10, 15 years old that were still making money hand over fist year after year.
Well, I mean, look at the industry right now. You got Aries and
That's the blueprint for the entire industry. I feel like, right? It's like we are a product of the fact that we've got all this tech legacy kind of tech debt almost, where it's like, well, Aries did this so well for so long and there were no other competitors. So it was just Aries and they had no incentive to go to the cloud or, like upgrade these things because there wasn't competition because they were the standard. And now you've got Combo Curve and all these other companies that accept, step change almost, right?
Jumping right in on them.
Yeah.
But even then it's still not even like,
no, yeah. They still have inputs.
You still have to pry Aries out of the bank's cold dead hands.
Well, no, yeah. They still have to have the import from Aries and the export to Aries and all this other shit that they wouldn't normally need if it didn't have this legacy stuff. But that's why, like, I say this so much on this, but like that's why our industry, and after working outside of the industry sort of for that year at HiveCell, we think it's unique to us. It's not. Like banks, like big industry has big industry problems, right? Like it doesn't matter where you're at. You've got legacy tech that, hey, it works and it's enterprise and it might still be running on a Windows NT server, but guess what? It works, right? Like I learned a lot of that at HiveCell when trying to pitch people on, this is why you should use Kubernetes. And they're like, well, what's Kubernetes? I'm like, oh, okay. I need to back up here.
What's a container?
So how did you pitch that? So Kappa's 6th generation architecture, 6th generation product that I'm working on now is Kubernetes based, and it's a pretty tall entry level to get in. Like if you think about,
tell you that HiveCell's no longer around, so there's a pretty good reason for some of that right there. But no, I mean it is like the whole idea was they were focusing on the problem, right? The problem was at the edge. How do I have reliability, redundancy, failover, all the things that Kubernetes provides
at the edge?
At the edge.
So you could stack these like servers onto each other and they would create their own cluster, and then you could have the Kubernetes that would go between.
I could deploy, with zero code, could deploy a 3-node Kubernetes cluster with a click of a button, which was awesome.
That's awesome.
But the minute I needed to move that from the test lab server network to the production network, if they weren't the same, Kubernetes doesn't like changing networks, by the way. Yeah. So that doesn't work. There's all kinds of fun bugs and shit with that. But no, the problem that we faced was a lot of, especially industrial software, is still on legacy VMs and stuff like that. So they were trying to figure out ways to get these VMs to run on these little, microservers and stuff. But that also felt dumb because it's like, over time, we're gonna move to containers. And
did they actually need all of Kubernetes to do that? I mean, if I think about a 3-node Kubernetes, couldn't you get kind of the same portability, redundancy with a simple Docker deployment?
Yeah, it's probably where we're getting too complex. And
that was the thing. They started with Kubernetes instead of starting with containers. We could run containers, but we didn't have push button deployment and all of that for containers because they assumed that everybody would want the redundancy and failover of Kubernetes. Well, when at that point, there were like 100 Kubernetes experts in the world. Yeah. And they're all making $500,000 each or whatever the hell they're making. And it's like, it won't be that easy. That was the problem. It's like even clients that were already containerized, they're like, yeah, we understand containers and we're pseudo familiar with Kubernetes, but we've never used it.
Right.
But going from containers to Kubernetes is a whole nother animal. That's not an easy thing to do. Yeah. Like the benefits make sense, generally speaking, if you think about it that way. But
absolutely.
Overcomplicating it or assuming that solving the problem would be the reason that people would migrate was not the approach.
Have you ever tried to build a Kubernetes cluster from scratch?
No, I don't even dare do that.
Oh my goodness.
It's crazy.
I wasted is probably not the right word. Yeah.
I learned the hard way.
I spent, I don't know how many days trying to do this and never did quite get it right.
Yeah.
I got something up and running after days and days and days of frustration.
I wish I'd have known that because we just had that podcast with John Farrell and with Josh with Well Database, but they're running Kubernetes on their own setup, but there'd be some good guys to reach out to.
I wonder if they're spinning them up themselves. Oh my goodness.
I think they were using Rancher or something. But but I mean, they're doing it on-prem, themselves. But
well, and that was the thing too, is it was like, okay, so we took this cloud-based technology, which is good, right, and proven.
Yeah.
But then we're moving it to the edge. But now you have to adapt it for the edge, right? So like the network.
That's the interesting thing to me.
How do I push button deploy edge a Kubernetes cluster to a frac van in West Texas when there's 200 megs of internet.
Yeah, that sounds like a terrible idea.
Well, yeah, it is. We found out that we couldn't deploy an instance unless we had at least half a gig, 500 megs up and down, or up, I think. But it was.
But I bet you probably could have done it with a Docker cluster.
100%. It was way lighter, right? And just, there's so much stuff with all
because and then the connectivity part is the biggest thing that we talk about a lot here. But it's like, I mean, Chick-fil-A runs Kubernetes on the edge on their nukes.
At the cash registers,
on like they have everything coming in from like all the different systems there into like
really
they have like
Chick-fil-A, like look into their tech stack because it's
some really good.
They're an interesting company all the way around.
Yes,
there's some really good Medium articles
there
on their.
They talk about
I'll
it quite a bit.
Yeah.
Them and HEB have actually done a really good job about talking.
about
HEB,
I believe HEB was ready for the pandemic before anyone else. I don't think they predicted it, but they had their tech stack in order to be able to just run.
But you think about like Chick-fil-A, right? So they've got the mobile app, right? So I order to pick up on the mobile app. I tell it what color and make my vehicle is and type of vehicle.
Right.
I get into the line. They've got cameras watching the line. They can identify, okay, there's a gray truck in line. I know that I have an order to go for a gray truck that's coming up. And then I, tell the person, right, you've got the GPS on the app. Like they've automated it. Like that's one of the reasons they're so good at the logistics of fast food, because
I didn't realize they did that with
so much
with the Kubernetes infrastructure.
Yeah, and then they have everything running locally. So if shit does happen, hey, they're
all self-contained.
So much money.
They do a lot of things right.
Mm-hmm.
They do a lot.
It's funny. We're talking about basically microservices. Because but I was thinking like for your original app, and it's probably one of those. You're the architect, and it's your job to tell me this is a terrible idea. But can you? I mean, I don't know if you can run. Can you run MATLAB in a container?
You could. It'd probably have to be a Windows container.
Gotcha.
We were playing.
That sounds you can, but I don't know.
No, I mean, like, I'm not advocating this is a good idea, but I was thinking
they do services
because I was thinking, that's the idea of microservices. Like, you could have a data scientist that writes in Python, and then you could write an API to that, and like you could call that, run it, serve it back to your main.
Yeah, the way we did that was they have a compiler, so we would compile down MATLAB functions pieces into C# and then or .NET Core. And then containerize that. I don't know if we ever containerized the runtime of that. I don't think we ever went that far.
Yeah. I want to know more about the graphics side because, Bobby, I mean, this isn't even remotely close to what you do or what you have done, but it's just like the perfect example of the things that the average person doesn't think about until you're developing for a project.
Deeped into it.
Right. Yeah. Until the client's like, no, I want to see all 1 second data points on our DFIT on the plot. And I'm like, well, sir, there's only this many pixels on the screen. Right. So it's not possible to show you the entire 1 second plot for a month on that one display.
So on that,
because y'all were doing wellbore diagrams. Y'all had a lot of visual data in there.
And I mean, we played it straight. We did, to your point, and these days with the GPUs, you can just throw a lot of data at it and let the GPU just crank. But in the end, your resolution is your resolution. You're always better served managing, I don't want to say filtering, but managing your data up front for the purpose of display. So to your point, model view controllers, model view models, right? Architecting it in such a way that you can separate your data from your visualization and then have a piece in between that you can control how that transformation happens is critical to good scientific visualization to make sure that you're showing what you want to show.
Especially when it's an engineering type workflow where it's like they always want the raw data.
Right.
They'd rather have the raw data and not need it than not have it and need it.
Yeah.
Well, and if you show anything rolled up and it doesn't look right, they're going to discredit it.
And you always have to be careful with the null points, which is a little bit unique to our industry, or at least from where I've like a lot of places don't have this notion of just not just empty, but just not there. Like but it's important, and on how that works. So
we're aware.
When
you're trying to plot a 1 second and it misses one
freaking
data point,
and
then there's a gap in the line, and you're like, oh, good. Well, I know I'm going to hear about this.
So, but I remember in my my early days at Shell, we were doing seismic, way bigger than you could display, and it was some of the first times that we were showing seismic. And in the early days before we did volume rendering, we were just doing 2D planes. But it was the first time they could see them in 3D, so they could do the classic take it on edge. You know how they used to take the piece of paper, put it on edge, and look down the. So we were doing that on the computer, and the geophysicists, they just thought that was the coolest thing that you could do.
Were y'all using because Shell had a shit ton of data centers around town, right?
Yeah, I was at Bel Air. I was at the Bel Air Research Center doing this.
But you had, Shell generally had a bunch of horse, like what was it, Cyrus One?
Yeah,
is what they call it now.
I mean, they had one of the first crays in the industry.
They have a ton of horsepower.
Yeah, we didn't lack for resources. So we had a bunch of SGI machines that we were doing this on. But the geophysicists I was working with, because they merged, they did a Shell Research. They had research geophysicists that they paired with the software team. So we were never on our own to do the science. We always paired, which worked out really well.
Yeah.
But they were on me because I made the mistake of telling them that I was downsampling their data. And they were they about lost their mind.
Yeah.
And so we had this long conversation. And so I put them up on the screen. I said, okay, here is your seismic. As much data, and I just threw every bit of data at this huge texture and put it up. I mean, that's what I want. And I said, there's not enough pixels. You can't see it. The hardware is merging, averaging, doing something. Wouldn't you rather have me do that in a way that we know exactly what you're seeing as opposed to a piece of hardware doing that? And he just looked at me and went, I want to see all my data.
Sure you do.
I don't know how to.
Yeah.
Yep. No.
Okay.
Bobby and I feel that pain. It's like they want to see it until you give it to them, and then they can't open it. And
Excel.
You're like, well, that's what you asked for, so figure it out.
I was just happy that Excel stopped, or finally had the option that they won't muck with your data when you open it.
Right.
Yeah. Yeah, that's huge. Like, I mean, because again, you give out an ID that starts with a 0. They pull a number
stamps,
out. Yeah,
all sorts of stuff. They just mucked with it.
Yeah.
It was like every time one of our engineers opened something in Excel, like, oh, please don't.
Yeah.
Just don't.
No, I had that. I was trying to run this chunking script that I've got the other day on these transcripts, and for whatever reason, some of the IDs had a dash at the beginning, right?
Yeah.
For the unique IDs for the transcripts I was pulling in, and I do most of my kind of testing and app scripts and Google Sheets just because it's quick and easy, and GPT is really good at coding app script. But I had it in there. I exported it to a CSV and then opened my Python and started to run it, and I kept getting this error for the one field, and I went back and found it, and it's every time there's a special character at the start of this file ID, for whatever reason in the output, it didn't export it properly. So I had to go back into Sheets, change the format of the column, and then magically it worked. I was like, this is the dumbest. The fact that I had to work around
I just cringe every time, until recently, every time an engineer opened it, he brought up Excel. I was like, oh, are you paying any attention? Please tell me you're paying attention to your data. Please tell me you know what you're doing.
Yeah, I mean, you guys probably know. I mean, we were providing like these 1-second data files, and I mean, every other week I'd get something. Oh, it's repeating the values. No, it's because you opened it as a CSV and you saved it as Excel, and you didn't format the timestamp before you saved it. And
it was just terrible.
The timestamping with all that stuff in Excel was such a
nightmare. And on timestamps, why people aren't doing UTC just universally.
Yeah.
And
I learned, I've seen a ton of people are like, pounding the table for it. I see now but the first time I ever heard about the ISO format was from you and Sean. And I was like, oh, that's cool. And then I see it everywhere. Like,
then we implemented it because that made so much more sense than messing with
this is in local time. Okay.
Yeah.
Yeah.
Really?
Yeah. I mean, I think it was for about a year or two after I was still like text like Greg, like, hey, just FYI, it's daylight savings. Make sure you guys, even after I was gone, I was like, I just felt bad. Like, it was coming up. I remember having to do that. I was like, just make sure you guys.
We got yelled at the other day because someone had continuously sampled data in local time, and wasn't converting properly. Went over daylight savings, and so the time was to whatever, and our conversion said that's not a valid time. Like, that time does not exist in the time zone that you're telling me it's in. You just can't do that. And the client was like, but this is, I understand. And, we can probably sort it out, in the software. We'll just keep a running clock or convert it ourselves. But that's just not a valid time.
Yeah.
No. I'm sorry. It's just not.
But then, isn't even like, maybe more like New Zealand or Australia, there are parts of the world even with like half hour, like they're half hours off. And then timestamps, we could probably go on about those. I remember I wrote like an app at RDS that would run on the data loggers so they could see it locally. And I remember the guy calling like, hey, this is wrong or whatever. And I was like, it works on Google. So Safari handled the JavaScript to handle the time zones different than Chrome. So it was like, it was not doing time zone conversion.
Languages handle local ones different too, right? If you're in TypeScript or you're in Python or whatever, if you call it local, it might be local to the machine. It might be like, oh, please.
Yeah.
What a nightmare.
Human hubris. We're so good at all this stuff. Well.
So we've heard, Reveal, a little bit about Shell Landmark. How did it all start? Were you the guy pulling computers apart at home as a kid, or if they were even accessible?
Interesting time.
I grew up in the 70s. My dad was an electrical engineer, and actually my first undergraduate was electrical engineering. So he had, there weren't PCs,
right?
There were mainframes running around, but it wasn't a PC. I didn't have my first PC till I went to college.
Yeah,
and I was one of the few people that I had. You'll love this. I had a dual floppy Zenith 4.77 megahertz clone.
Oh my God.
DOS,
that's
whatever.
Incredible.
Yeah. And it was as good as you could get.
Dual floppy.
Time.
I've never had a dual floppy.
Dual 5.25 inch
the big boy. Yeah, the legit floppies.
Yeah,
that was my first computer.
Yeah, I don't real floppies.
Yeah,
right?
I don't remember the brand, but I remember putting those damn floppies.
Yeah. Did you have enough RAM to run Slack or not?
Definitely not. Not even one Chrome browser.
Oh my goodness. It's a little, it's interesting to watch. One of the things that I was thinking about before I came in here was every machine I bought from that very first one all throughout the years is on the order of 3K, no matter when I,
right.
Yeah. I always build them out for development.
Yeah.
So I'm always, and being a visualization guy, I always get the highest end graphics card that I can get.
Yeah.
And every machine from that very first 4.77 megahertz, because they couldn't get the 5 megahertz to run right, through the MacBook Pro that I have today is always in the range of 2,500.
I just spec'd a new MacBook Pro, and that's about it was the 64 gig. Because I was like, well, if I'm gonna get a new laptop, I might as well get a Mac since I'm coding shit now and make my life infinitely easier. But
before I forget to ask, they've had the new chips for a year or two now, right? An M1 chip.
The M1, I haven't played with one yet.
Oh, you've
still have Intel. My Pro is the last Intel.
Okay.
Colin loves
I probably should have waited another.
Yeah. Well, I know initially, I'm sure they've worked it out now, but I know a lot of developers were having issues initially with like M1s, like just the catching up.
It's interesting that they've gone, to me, it's interesting. They went from Motorola to Intel, which was a nightmare of a shift for them. I don't know. You guys probably don't remember that shift. And now they're gone to their proprietary chip. But this shift seems much easier than when they went from Motorola to Intel. They had all sorts of compatibility problems.
Yeah.
This one seems much better.
Yeah, Colin was talking about today that the M1s are on sale at Walmart for like $600.
No way.
The errors.
And I've been told, I haven't looked at the hardware architecture. I've been told that's an integrated graphics chip.
Okay.
So they've gone, which if it's true, and I haven't looked at the Pros because typically the Pros have a designated GPU and them, usually the ATIs.
That's what I was looking at for the.
Yeah. So they still have the offer of the.
I believe so. Yeah. Because I was looking at the whatever RTX.
Yeah.
5
right.
6. I was like, oh, that's twice the price of the laptop.
$3,000.
Yeah.
All right, so you had the best computer at Tulsa.
So I had the best one of the few PCs at Tulsa, and my first job out of school was as an electrical engineer at McDonnell Douglas, doing what they call glass cockpits.
Okay.
So the F-15 Eagle,
nice,
that's awesome.
Back in the day, was one of the first fighter aircraft with an all glass, all digital display cockpit. So they had one hard instrument, the altimeter. They had
okay, so that's what you mean. Instead of analog gauges,
instead of analog gauges, it had just all digital displays. It was the first one.
That's crazy.
First one, yeah. So I was doing that.
Was that just like the green OG?
Yeah. Oh, and it was stroke. It wasn't raster.
Really?
It was all stroke display. Yeah. That's an interesting environment to work in. The oil industry is an interesting environment to work in, but military, also an interesting, a very challenging environment to work in for a lot of reasons.
Yeah, they have a lot of really interesting nuances that you don't think of as the average person. One of my professors in undergrad she worked at Lockheed in their missile defense stuff.
I almost went to work for Max Missile. Yeah. That was a little too aggressive.
Yeah, it is rather close to the impact point, so to speak. But I asked her. This was in college. I was like, "Well, what language are y'all programming?" I don't even know what I suggested because this was the early 2000s. So I don't even know what languages were around back then. But it shocked me when she said Fortran.
Yeah.
And I was like, "Oh, why are you using such an old language?" And she's like, "Well, all management. That's what the management knows.
Military.
And if you can't do it in Fortran, it's not optimized enough, right? And it's also the lightest weight version that could essentially
It might have still been Fortran 4. It's probably 77, but still, I mean, frankly,
when you think about a military thing, you don't have, you're not trying to optimize hardware. No. You've got a minimal amount of space. It's got to run off the minimal amount of battery and all,
that. And then, we've talked about this too, but like just the cost or the risk of, refactoring it, and it works.
Right.
Yeah.
If it works, it's hard.
Yeah. It was one of my first lessons in, it wasn't my project, but one of my first lessons in redundancy. While I was there was a story that came out, one of the space missions. They had a scrub a launch. And at the time, they had redundant hardware systems, all built by different contractors to the same specifications. So the way the military worked, I found this fascinating too. As McDonnell Douglas being a contractor, effectively, you bid on contracts, but the first bid was proof of concept. So like if you bid on a say like the F-23, F-24s, part of that contract was you gave the government all the specs. That's what they were buying, and then they could give that to whoever they wanted to. Typically, they went right back to the person that designed it, but they didn't have to. So what they did with the space industry was they actually did that, but then they farmed it out with the idea of being redundant. So you had the same spec, but two different implementations. Right. Chances are if there was a bug, it'd be in a different spot. So if a system had problems, the failover would be a completely different design.
Code base or whatever.
They didn't do that with the software.
Oh, okay. So
they had to they had to scrub a launch because the main system went down, aired out, went down. The backup system came up, aired out, went down, and the third system came up, aired out, and went down. They scrubbed the launch. They had loaded the exact same piece of software on the redundant systems, and they had a bug in the software, and the thing went.
Oh boy!
It's one of my first lessons in redundancy.
Awesome. Talking about the government stuff, did you see it was like a couple weeks ago? I think the administration, the Biden administration, came out and said that they want to start moving to refactoring like code bases, like government code bases, to be memory safe and like
probably a good idea.
To be optimized. Like, and it was like, but it's interesting that it would come from that high up.
Yeah.
And then it's like basically, without saying it, they're basically telling people to go use Rust, because I think a lot of these things were C++. Like the only way we're going to get that performance and be memory safe is Rust at this point. But it was interesting to have that decree from like a government.
Well, I got to believe these days with all the cyber hacking and everything else going on, they've got to be, they have to know it's a weak spot.
Yeah.
They have to.
I can't even like begin to fathom all of the shit that they have to, like, being an IT security person for any governmental agency. Like,
I
what
mean,
a complete nightmare.
Absolutely. Like. I mean, hats off to him, and with good reason.
Yeah.
I mean, it's a shame that we're in that spot. But man,
although
I mean, I couldn't imagine.
It does sound like an incredibly fascinating job. I've been listening. We went, spring break was last week, for just to give everybody a reference whenever this does come out. But we drove to Florida and back, and so I was listening. I've been on this podcast, Darknet Diaries. It's I think he's a white hat hacker, but it's all it is 30 to hour long episodes about different hackers or attacks or different things. They had some of the NSA. They had a couple NSA guys on, and they were talking about the guy's main job when he first started. He kind of helped start, their red and blue and red teams internally and stuff. And he was like, it was our job to literally just try and go in and be undetected in the network. Like that, their whole job was pen testing and hacking their internal network.
How much fun would that be?
Yeah. And he was like, we would mess with people all the time. Like we'd go into the server room, like they do all this stuff, because they were on prem too. So they could really get crazy into with stuff, like someone leaves their computer unlocked, they could go plug in a USB drive, or like they would do all kinds of stuff. Like that would be super fun. Trying to defend that on the other side sounds miserable.
Yeah. Now, have you read, I'm going to date myself even more than I already have. Have you read The Cuckoo's Egg?
No.
Cliff Stoll. It would be, you might find it fascinating because the technology is so antiquated that you'd be going. So in the end, he finds one of the first people to detect a hacker in the system back in, and this is before the internet. This is ARPANET, and the way he does it, it's a fascinating read because it's a first person, and it was one of the first, like, people didn't believe him.
Right.
It was all due to an accounting error. He was working in what we would call IT, but back then it was something else, and there was an accounting error. It was off by like a half a cent or something.
The Office Space hack.
Yeah.
It's just a fraction of a penny.
That's what it,
that's a lot of pennies.
And that's what it was. And
a minute detail.
And it bothered him because it can't be off.
Right.
Like,
it shouldn't.
No, accounting.
It could not have been off. So it bugged him, and he started tracking it. But it's called The Cuckoo's Egg. It's one of the original.
That's
one
awesome.
of these original hackers.
That's a good one.
It's not very well written. He writes it. It's fun, but it's a great story. But in hindsight, but very cool.
That's it's amazing how much of that stuff. The last one I listened to, there was a 2-part episode on the Xbox Underground hack, which I had no idea that was even a thing. I knew people were hacking Xbox, modding Xboxes and stuff, and hacking them because I'm still a gamer nerd. But it was like somebody found a Xbox dev board in a dump, and this is where Microsoft was just trashing their dev boards, but the dev boards for the Xboxes were like the prototypes,
right?
But they were just full Xboxes. They didn't have a case or anything,
right?
But it allowed you to get onto the dev version of the Xbox network.
Oh, wow.
That had all these. They would have game like demos and stuff up a year before the games were ever launched on the network, so people could play them and beta test all this stuff.
Right.
The way they got in, they had these boards, and then they just started going through and trying password, normal IT passwords, and sure as shit, they got into whoever Activision's network, and then via that they got into all, because Activision works with Xbox, like Microsoft and all these other companies. They got into all their network. It was nuts how like deep this went, but it was because
because you didn't dispose of your hardware.
They didn't dispose of the hardware, and they used the stupid admin password, admin password. And I mean, given this is early 2000s, so it's not like they were password managers or anything. But at the same time, they ended up then finding like an Excel file that had all of the IT passwords in it. And so they had full access to everything. Like he was reading emails from the FBI to the Activision developers about their hack. Like it was wild. Anyway, shout out to Darknet Diaries. Go check them out. They've got some really good stuff.
Did you ever hear of the original internet worm?
No.
87, something like that.
Yeah, I was 2.
Oh, I wasn't. I wasn't breathing at that point in my life.
Almost. It was something else. Another one interesting. It would propagate through the network, and it would compile itself. So because you could find CC and compile itself, and then it would screw up your network. So we had heard about this. I was at the university at the time. We heard about this, and so our defense, which I thought was awesome until it was was we simply renamed the compiler so it couldn't compile itself. And then we could isolate it because we could see it come in.
Right.
And so we actually watched it come through the university, isolate itself, or try to compile itself. And we isolated it. Yeah. Which was brilliant at the time until I couldn't get any damn work done because I couldn't remember what the damn compiler was.
No, but that's what's so fascinating about. I've listened to a number of episodes just kind of in a row because of how many hours we were driving. But so much of it still is just like, it's not actual hacking; it's social engineering.
Yeah,
right?
yeah.
It's just like
it's easier way in, right?
Oh yeah,
it's much easier way in than actually.
Yeah, I guess one more thing. I didn't know we were going to get on the cybersecurity stuff, but I think I sent it to you. But like there was like Cloudflare has like this wall of lava lamps.
That's insane.
And like basically like they've got something. I'm going to mess it up. I'll send it to you. But like basically just the lava lamps going up and down are so unpredictable. And then they encourage people to walk in the room because that changes the way. But like the computer is using that to like swap out like the code, like the.
Cool.
It's the encryption.
It's the seed.
Yeah. It is no, that's exactly what it is. They've got cameras.
That's brilliant.
And it's live streamed. Like you can watch the lava lamps, and it's literally just a giant wall of lava lamps, but each lava lamp is tied to a seed essentially. And because lava lamps have a unique motion, it's impossible basically.
And again, they encourage people to walk in there because people walking in just crowds those like almost like chaos theory kind of thing.
Brilliant. Yeah, I was like, that's incredible. Actually,
stuff.
I love analog to digital type stuff.
And I have to say, shout out to Jeff Hughes for sharing that to me because it said Cloudflare, so it has something with cloud in it.
There you go.
Jeff,
I love it.
Jeff is the anti-cloud.
Yeah. Well, I told him to Jeff's like, yeah, I go to the Goodwill and get 10 lava lamps and do that in my office. Yeah, but
go for it.
Yeah,
Jeff will do that.
I was giving him a hard time. That's what I suggested, but no, it's all good. All right, so
from F-15s to this is kind of an odd thing in today's. I ran a neural net research lab for McDonnell Douglas in the late 80s, early 90s.
Okay,
in kind of the second wave of AI that.
It's a very common theme.
We're way before our time.
We're seeing is that technology isn't linear, right? It's this very cyclical thing, and it comes in, or it can be very early, and then it can come in again, and it's still there's still not everything needed, and then now it feels like it with the AI
it's coming
stuff.
back.
Yeah, there's the internet. You have all the information you need that you can compile to do it. Now you have the compute power to do it.
Way before any of the networking.
I can't even imagine.
We didn't.
The hardware.
We generated. I know for a fact we generated 2 PhD dissertations because I got acknowledged in them. Giving those away, thank you.
Where's yours?
Jeez, I'm gonna keep those. So that was forever ago. We were doing all sorts of stuff. It's interesting to watch it come back around after watching it, after seeing the promise and then completely failing. Frankly, it's 30 years later, but I'm kicking myself for not
getting off
staying with it for all that time. But we did all sorts of strange early days, not knowing what we're doing.
You think it primarily was it a hardware issue, or was it a knowledge of the understanding of how all that shit?
I think it's both of it, because the core pieces. If you look at what we were doing back then, we had backfeed neural networks and we were doing self-organizing Cohen nets, which were very cool. Hard to understand, but very cool. We didn't have enough horsepower to train them properly in any reasonable time. We didn't have the data sets. Yeah, we didn't understand that we didn't have the data sets.
At the time you're like, look at all this data we have.
Right.
Like, now you're like, fit on my
so we didn't really understand the training side of how important the training side of it was and what that looked like. And, in hindsight, we did not have enough data to train these things properly. We didn't have and some of that was because we weren't connected. And so we were working with whatever we were doing, satellite imaging, recognition, automatic satellite imaging recognition, that sort of stuff. We're trying to.
What kind of resolution did you have? when you were working on that?
I think they were 1024 by 780, whenever. The satellite images actually were quite small. I might still have a few running around somewhere. Spot data. I'd have to go look.
As far as like the actual,
like the screen.
how
oh, the satellite?
Yeah, how far you could zoom in onto a.
Well, we were doing parking lots. One of the more interesting things is we had satellite data. We're in St. Louis. McDonnell Douglas is in St. Louis. Had satellite data downtown St. Louis, and we had a self-organizing network that was trying to analyze this. And one of the clumps of the self-organizing network, there was laid in between two other things. We couldn't figure out what was going on. We finally figured out that it was a parking lot that had been patched with asphalt, and so it had properly recognized asphalt, and it properly recognized concrete as clusters,
right?
And then it had this weird thing in between that we believed after was this patched.
Oh man.
So we had enough resolution that we could see that, but they were still pretty small. We just didn't.
No, I think that's one of the biggest things that people just the average person doesn't understand about all the AI and ML stuff is that like you can think you have enough data sets, but it's all of those outliers that if you don't have that data set, you can't train the model on it. Right. So when the Tesla is driving down the road and there's a parked car in the middle of the highway that, has cones or something around it, it doesn't know what the hell to do.
Yeah.
And that's what happens. And so, but once that happens, now you got a data set and you can train it. And
that's
things get better, right? But it's that 1 or 2, 3, 5%. It's that last little piece that like, 95% sounds good enough.
I mean, I just thought about this stuff, but at the same time, humans are like that too. And so we've seen certain situations. And
that's how we learn.
Was it in here? Was it George talking about it? But training executives.
Yeah.
Like simulating, because executives haven't had to go through like a COVID or something like that. Yeah. So but what if you could like simulate? Again, airplane pilots go through all these different simulations and stuff before they can get in the cockpit. Like, I mean, why should put a CTO through different types of simulations, so they know how to? Maybe they're more equipped to handle a catastrophe when it happens. Or
now that gave me the idea that we had that interview, and then last week was spring break, so I'm listening to all these podcasts, and I'm like, why the hell don't we have this for cybersecurity? How great of a tool would that be as an IT person to be like, hey, guess what? It's our quarterly attack day.
Right.
So everyone, step away from your shit and we're going to go into the simulator and we're going to actually simulate, a Trojan or whatever, a DDoS attack, whatever it may be, and see if you guys actually can fix the shit. Especially in energy where you've got infrastructure and physical assets tied to all the digital stuff, right?
Right.
There's a lot of, I feel like, most people, you don't, unless it happens, you're not
absolutely.
You don't really know until you know.
Absolutely. On 9/11, I was at SEG in San Antonio, and that year, or the next year, I was on the committee for the SIGGRAPH conference, big conference. And in that timing, so I'm watching this happen, right? And we had talked as a committee over and over again about emergency situations. What do you do if this happens? What do you do? How do we handle these things? Because you don't think about it. And how do you go through this training? So here I am at 9/11, chaos. And it's strangely, I don't know if you were there, but at SEG, it wasn't really chaos. It was just unknown. So everyone was just kind of standing around trying to figure out what was really happening. And the conference, of course, is now trying to figure out how do they deal with it. Well, I'm on the phone with the conference chair to the SIGGRAPH conference chair going, this is what they're doing. I'm learning in real time because it hadn't even occurred to me that something like
that could happen.
No, I vividly remember being like,
if you're on the leadership team, now what do you do? So it's certainly, these learning notions, no matter human, machine, whatever it is.
No, that's a $1 billion company. So whoever wants to send me the royalty checks on that, I'll happily collect them if you want to build it. But
all right,
we're already
getting
bumping time.
Yeah, I think let's talk about how you then got into oil and gas, from there, and then we'll jump into our.
So I mean, it was frankly, I wanted to get back into visualization. So I was doing, and that's what my research was in graduate school. And so Shell got a opportunity at Shell Oil at their research lab to do visualization. So cool. I showed up in Houston in 2000.
Okay.
Thought I'd be here 5 years. It's
hooked you.
And I did their first 2D seismic. I did their first volume rendering in seismic. And then from there, I went to Silicon Graphics. You guys remember Silicon Graphics? I spent 10 years there doing applications for oil and gas, but also simulation. I had a bunch of different clients. All the oil and gas clients were mine, but I also had ones outside of it. So I spent 10 years at Silicon Graphics until bankruptcy hit. And then Halliburton, 10 years. Okay. So from there, Halliburton was at Landmark.
Yeah.
Landmark was a client of mine. So it was I talked to all the big, I was fortunate, frankly, that Paradigm, Landmark, Schlumberger, I knew them because they were all my clients.
Yeah.
And so as soon as they had heard that, Silicon Graphics was shutting down their graphics group.
Kind of a key component.
Yeah. It was I slid over to Landmark. That's where Sean and I had known each other for a long time, and so I basically decided I wanted to go work with Sean.
Nice.
And then Sean left almost immediately after I went to Landmark, and then he ended up at Reveal years later, and
that's awesome.
Just rolled around with it.
That's cool.
It's as you guys know, this industry it's not really a good old boy network, but it's not very big.
Not big.
No,
it's not very big.
Especially once you get into your niche or whatever, right?
Right.
Oil and gas, you got energy, then you've got oil and gas, then you've got graphics.
Now,
or like technology.
Compared to you guys though,
graphics,
like I never thought of myself as an oil and gas person. I've been here now 25 years, but I always considered myself a computer scientist. And everything I've learned has just been, to the credit of the industry, people are very accepting.
Yeah.
Like, they were more than willing to teach me to listen. And
the big, like my favorite thing about this industry is it doesn't matter who you are, where you come from, what you look like, what your background is, if you've been arrested, like anything, if you're willing to put in the effort and show that you want to learn, people will absolutely help you and teach you. It is absolutely like, I feel like there's not a lot of industries where that is so like, it feels like it's not warm and welcoming from the outside, but once you get into it, it's like, my company man might cuss me up and down because I screw something up, but then the next minute he's teaching me why that happened so it doesn't happen again. And that's how you learn, right? Like it's just
one of my first, actually, I think it might have even happened in the interview at Shell. They had their 3D seismic interpretation system. So they were showing me data. They were showing me their 3D data on this 2D display. And I knew nothing about any, like I knew nothing. And I was looking at it going, that's not 3D. It took us the longest time to sort out that their data was 3-dimensional, projected onto a slice of it, where I'm sitting there going, but
where's the turn? Where's the Z? Where's the Z? There's no Z here.
This is 3D seismic.
Why is it in X and Y?
Okay.
Whatever you say.
That's funny. I want to know what you think about, and this will kind of roll us into our kind of little speed round. VMs, containers, or Kubernetes, what would you build on today if you are starting? And I know that's a loaded question because there's lots of variables.
Yes and no. Today I would not do VMs. I would do, and I would have done containers probably 10 years ago as well. We were starting. I'm a big fan of containers. It's I use them all the time.
I was going to say, as is everyone who uses them.
I don't install. If I can get away with it, I will not install software on my workstation. I'll just spin up a container and use that service. But as you know, as we're doing with Kappa, there's a time and a place for Kubernetes. And what we're doing there is certainly a time and place for it. If you're doing very large scale, redundant, failover, rollout, I don't want to say professional grade, but if you need the ability to roll forward, roll back, recover.
If it's enterprise stuff, it's probably, especially with high volume use, like users and volume of data.
But I would not, if I was starting from scratch, I probably wouldn't start with Kubernetes. I'd start in a containerized world.
That makes sense, right? Because a container is basically within a Kubernetes cluster anyway, right? So build inside.
Hell of a lot easier to get your hands around.
If you actually need to spin up your own Kubernetes, now with some of these cloud services, I mean, I can take my container and put it, on a managed service. Again, there's pros and cons to that too with price and whatever else. But I mean, I remember you were asking me about some of the stuff when you were at Hivecell, and I was like, I can do that with Azure Container Services. He's like, wait, what? Huh? So, yeah, I mean, I think you graduate from containers to Kubernetes if and when you need it. Right. I mean,
that's what I would do.
When it's not one of those, like, I feel like it's been touted as like the thing, right? And like people are like, oh, well, I need to build my stuff on this. It's like, you don't always need to build your stuff on. Like Kubernetes is a very specific, like, there are conditions that you need where it's like, yes, Kubernetes makes the most sense versus I'm just running this script on my laptop. I don't need a Kubernetes cluster.
And I'm certainly not doing that for myself.
Yeah.
That's for sure.
Sweet. All right, I'm gonna jump in the speed round.
Yeah. No,
your speed rounds, by the way, you're unfair. So I'm gonna go back at you on the speed round too.
Cool.
I would listen to them. I'm like, wait a minute, they never have to answer.
Yeah, that's true. That is true. Maybe we should flip it. And you ask us questions for the last few minutes.
I'm going first though. What's your favorite visualization library?
Ooh, that's a good one.
The one I've been working with recently, and frankly, Sean wrote it, so it's a little bit in-house, is called Next Scene Graph. It's a C# scene graph. It's one of the few C# scene graphs around.
Okay.
It's built on top of another really cool graphics package called Veldred.
Okay.
The nice thing about Veldred, as opposed to Vulkan or Metal, it's and there's reasons not to do this. It hides away Vulkan, Metal, wherever. So you can write against Veldred. It's typical, one level of indirection here. You can write against Veldred fully with shaders and everything else, and it will move to the back end appropriate for the hardware you're on. So I can write a visualization. I can run it on my Mac and use Metal.
Okay.
I can run it on my workstation at work and use NVIDIA. I can even do it in
that's nice.
Windows.
You don't have to have a specific
So Veldred is very cool, but it's like Vulkan, right? So we're back in the days of sort of linear programming. Next Scene Graph, I think on NuGet it's actually a Veldred Scene Graph. We call it Next Scene Graph. Is written on top of it. It's a very cool little package that's written by one person.
And again, born out of the oil and gas industry.
Born out of, Sean wrote it because we wanted to do 3D for Reveal, and there's just not in C#. Just not very.
Leave it to the energy space to, hey, this doesn't exist and I need it, so I'll go make it.
I'll go do it.
Yeah.
I'm always buy versus build, but we couldn't.
Well, yeah, if you can't buy it,
we couldn't buy it. Yeah.
That's funny. And we need to get him on, but like my buddy Brock Meyer, they wrote their own visualization library in React, actually. For what he was doing, but then allowed them. He had some guy from Ukraine helping him, and they built it out, and it does some really cool stuff.
Yeah.
What is your preferred database?
Oh, I don't like databases.
You're a graphics guy, right?
I'm doing databases right now. In fact, I was just complaining that of all the things in computer science, like databases is the thing that interests me the least. It's probably one of the most important things.
I was going to say, the whole internet is built on relational databases.
Don't get me wrong, I get it. Like, there's a reason, but I just don't.
It's a means to an end for you. Huh?
Yeah, exactly. Just give me my data. I don't really. Yeah. And here I was today, literally writing SQL queries, asking. Actually, I was using Microsoft's Copilot.
Copilot, yeah.
Because
I will never have to learn.
Copilot's amazing.
I'll never have to learn SQL because of the language.
Oh my goodness! But frankly, I went round and round because it would not correct itself.
Yeah.
I kept asking it, but that's not right. And it was like, no, oh yeah, you're right.
You're right.
It gave me the exact same thing. Like, oh,
you're
killing me.
I'm noticing that becoming more common actually, where I don't know if they're trying to like optimize for tokens or whatever, but it's like because I would give it, we'd write some code, or I'd throw some code into it, have it modify it, whatever, and then it would abbreviate and just return the new pieces,
right,
and then be and then the rest of your script, and then the next one I was like, well, that doesn't even tell me where I need to insert this, right? Like if it's not replacing a function, I don't even know where in line that this needs to go. So then I'd be like, and always return the full script or whatever, and then it would keep doing that, and you're just like, but if you keep doing this, then I'm just wasting tokens asking you to give it to me again. So like it's really not optimized for cost.
I don't know what's going on.
It's nuts, but
I'm also a big fan. So for me personally, if I'm not in SQL Server, if someone else hasn't done it, like if I have to do it myself, it's probably MySQL, or
the one with the dolphin,
something simple, something simple,
that or being Postgres is really powerful. But again, to your point, it's like unless you're doing something where you really need like some variability, it's like it's SQL. If you normalize it and do it properly, you probably use an ORM anyways if you're doing software development.
I always, for me, because I'm not a big database person, like I'm a big fan of Dapper.
Okay.
So
no, that's what we're trying to get. Any cool tools that you use that you love that the average person might not know about?
I think Dapper's pretty, in the C# ORM space, I think Dapper's pretty obvious, but for someone who is not a database person, it simplifies my life.
Cool. But even if you are a database person, at some point, like you want portability, and if you want to be able to swap out, this database for that reason or whatever. I mean, again, we were talking about Well database, and they're swapping out SQL Server for Postgres now, just because they don't have the licensing costs, and they have an ORM, so it's very minimal code that change at that layer.
Right. Because they don't make it easy to go off of whatever server you set up on in their cloud for cheap, so they could get you hooked. Or, we got like Google has all these ingestion connectors to pull in your data from wherever to BigQuery.
Right.
Like, that's really nice. And then I started thinking about it, I was like, because they don't have any export to anywhere else.
Yeah, it's
like,
sticky.
They did a good job on the ingestion. There is no output.
And they're free to ingest. Like, say Snowflake, when the computer's on, whether it's writing, reading, whatever you're paying, BigQuery does not charge you on the ingest. They only charge you for on the read.
On the read.
But then they charge. They have
I'm sure they charge you out the ass if you're trying to move it somewhere else.
Yeah. Well, then you pay all the egress.
All right, I got one for you.
Yeah.
What was the last thing you learned?
Oh God. It's got to be around the code that I need to make sure I format my Google Sheets before I export them and start playing with them in data frames, because that matters.
So I'm going through a home buying process right now, and I learned that you can assume a VA loan.
But there is no incentive.
But there's no incentive for the seller to let you assume it.
Because if you do, they can't take another.
Really? So I was looking at this house, and my realtor's like, I'm going down this rabbit hole. I don't think we should probably do it, but let's investigate it, because if I could assume it, I could take over their 2.9% interest rate.
Right.
But it's there's no incentive for them, because while I have assumed it, that veteran cannot use that VA benefit.
Oh.
And then if I were to ever default, then they would lose that benefit forever.
So there is no incentive.
Yeah.
And then we were talking about the government earlier. Like, it's apparently, even if everyone was amenable, it's like a 3 to 5 to 6 month process. That's just brutal. Easy. Like I think they have more rigorous inspections, and it takes 3 weeks to get this one piece of paper pushed across. And,
interesting.
But that was
it's a nice thing to know.
Yeah.
Mm-hmm. Yeah. The other one would be just all the stuff from the Darknet Diaries podcast is make sure you don't leave default passwords in any of your architecture. It is genuinely amazing. Like
what they could
how
find.
much they. Because like I said, like the Xbox one, it wasn't just Xbox.
Yeah.
And they fished all the auxiliary partners of them and got into their networks, right? Like it was, I mean, FBI got called in, all this shit. Yeah. A lot of them went to jail.
Something I learned too about, more tied to my day job, which is a small nugget, but again, that's what we're all about sharing here is if you're using Snowflake, you can set all your different kind of compute to auto suspend.
Yeah.
And it used to be the minimum was a minute.
Yeah.
And I found out you can crank it down to like 6 seconds or whatever.
Nice.
So
really?
So now you're because like if I ran a 10-second query, you're gonna get charged for a minute.
Right.
But now you can run a 10-second query,
like
and
the
get charged for
lawyers.
16 seconds because after that first minute, whatever it was, or whatever your auto suspend, then it's prorated per second. But now we can pull it all the way down.
How fast is it to spin back up?
Immediate.
Really?
Snowflake is so, and I can't speak for Databricks, and I think they're trying to get there. And I don't know about BigQuery, but Snowflake keeps like these warm servers under the hood. Like, so while, I mean, I can have like a DAG of different SQL queries, and like within the SQL, they have ways to take your warehouse and make it go from a small to an extra large, which would, I mean, what would that, I mean, let's say just easier would be small to a medium, basically doubles the cores.
Yeah.
You can do that instantly.
Snowflake is on my to-do list. So
it's
that's
pretty
interesting.
I don't have anything in there yet, but it is incredibly easy to set up.
Yeah.
The only reason I did BigQuery out of the gate was because I knew it had it's free to ingest, and I knew we had
but what's funny though, that the whole auto suspend thing too, and I think in that same thread where I've learned that, I shared, there's a really good blog post from a couple months ago where this guy's like, I accidentally saved my company $500,000. So I guess, and he goes through just the total ineptitude of the company, and like how it took like 2 years for them to allow him, or for him to find the right person that would actually push the button to take the auto, but they just left the default auto suspend at like 10 minutes. So everything they're running in, like, you have a bunch of Power BI hitting it, and like things run, and then they charge for 10 minutes.
Right.
So then 2 years later, he finally got the right person. They hit the button down, took it down to like 1 minute, whatever the minimum was. And like everyone was losing their minds the next week. Like, we're going to save all this money. Like, and like, it was just, again, just knowing the tool you're using. And
I'm sure
people want to say the cloud's expensive or on-prem's expensive. I mean, they both can be true and both can be wrong. I mean, like, but you have to know the tools you're using.
That guy will get laid off in 3 months, I'm sure. For no fucking reason. But that's how the industry works. Yeah, that guy should get a commission from that savings for sure.
But
that was already an hour. That was quick, man.
That was quick.
Fun. We need to have you back. It's been good seeing you. It's been a while.
It's been good to see you guys.
It's fun to talk shop. Where can people find you and get in touch about it?
I'm not real active on social, but they can find me on Twitter at ssefton, I believe. I think Viz Alchemist is also there.
Oh, nice.
LinkedIn is probably the easiest place to find me.
Is Reveal under Kappa now?
Reveal, yes, the Reveal website is moved under Kappa now.
Cool.
Sweet.
Appreciate you coming on, Scott.
Oh,
yeah, thanks for being here.
Good to see you guys.
Yeah.
Always fun to talk.